Hey everyone, I'm Joe, back again with
Blythe.
And today we're going to be having a little bit of fun with a version of the game pong.io, which if you've never heard of the game or have never played it, it's the basic idea of it is you are this little blob that's moving around the screen and the board. You're trying to move around between various obstacles and other objects and try and hit other players off the board while also not getting hit off the board yourself, because that's how you lose, is if you get hit off the board. So it's a pretty fun game. It's one of the most popular games of the .io games. And it's pretty similar to the Pong game that we showed you guys earlier, but it's got a few more nicks and twists to it that we'll show you here to it. One of those things being gravity, which we'll talk about here in a sec and how we're going to put that in. But just to start off, we're going to start off with a modified version of the Pong game that you guys probably have played earlier if you've watched the earlier video for Pong. So we'll go to this. As always, click this button, get rid of bring the console down. We'll drag this over so that you guys can see. Code will just run it here initially for you guys. And you notice nothing really actually happens with the ball. It's just stationary there, and why is it doing that? Well, we don't actually have gravity put in. We don't have an initial velocity in the X or the Y direction. And just something, a side note for you guys, is a lot of the previous videos we've been doing, starting off with 1D motion in the X direction and kind of modifying the code to add in the Y direction. So here we're going to start off with motion in the Y direction, and then we're going to modify it to try and add in the X direction. But we'll just go back over here to our code and take a look at some of the things we have. So we got our X and Y as always. We got our initial velocity in the X direction, our velocity in the Y, which are 0 as I said. We have our delta Vx and our delta Vy, which is going to help us change our velocity in the X and Y direction. We have our mass of the blob, our change in time delta t, which is equal to 0.1. We have our g is 9.8, which that's going to be the value we're going to use for gravity. And for any of you physics nerds out of there, 9.8, this is on the Earth, value of acceleration on the Earth, so it's not like on the moon. So if you played the lunar lander game that we had up for you guys, it's not 1/6 the value. We're not on the moon, so we're going to be playing this game on the Earth for right now. Then also we have the size of the blob. Keep going down. We have our draw function with our velocity in the Y direction and our position in the Y direction, so how we're going to update each of those. So like for our velocity in the Y is equal to our delta Vy. Then we have our Y position, which is our Vy times our change in time, our small change in time, delta t. And then we have our acceleration in the Y, which is equal to 0, which again, as I said, is the reason we don't have any acceleration going on here. Then we have our delta Vy, which is equal to our acceleration times that infinitesimally small change in time, delta t, and that relates, the acceleration times our time relates to the velocity. Then we also have our if statements here, which if you guys have looked at the Pong video at all before this, you'll notice this if statement is very similar to what we had done in the Pong game. Then we also have our display function to then draw out our force vectors and draw out our blob. But to get this code to get this little blob here moving and to add in gravity, Blythe is going to tell you guys a little bit on how we're going to add that in.
All right, so we're still going to start with a 0 initial velocity, but we're going to change our velocity vector by adding this acceleration. So let's go to our acceleration variable here. We're going to add in the minus g. So the minus means that the acceleration will be pointing downwards at all times. So that's like, the downward force of gravity that we feel on Earth. So let's see what happens when we add just that one component in. Okay, so we see a constant length force vector and acceleration vector, because it's related to that constant minus 9.8, that minus g. And we see our velocity vector grow and contract. So we see that it gets further down as we get closer to the ground, and as it comes back up, it gets smaller as we head towards its peak vertical position. So that was just motion in the vertical direction. Let's see what we can do to get some horizontal motion in. So why don't we introduce motion with the initial velocity, so like we had with our blob in the Pong game. We'll give it a non-zero initial velocity, so we'll just change this Vx component to 15, say, and let's see what happens when we do that. So move this over. Okay, so now we see our velocity vector now having a component in this in the right direction, so it's not just pointing straight down. But while our velocity vector is reflecting our update to the initial velocity, our ball isn't actually moving the horizontal direction. So let's see how we can fix that. So as I come down here, I see this part where I'm updating the location in the y direction, so it looks like we need to update the location in the x direction as well. So that Vx times delta t. And we also see that we have this line that's updating the velocity in the y direction. So if we were to have an acceleration in the x direction, we'd also want to update the velocity in the x direction. So let's put that in here, just in case we happen to have forces in the x direction later on. Okay, so let's see what we have now. Okay, so again we have this velocity vector pointing down and over to the right, and now our ball moves down and over to the right. So let's see if we can get, instead of just setting a initial velocity in the x direction, we can actually add some forces in the x direction as well.